This short episode is about an international effort to get us closer to a philosophical understanding of who we are, how we got here, and where we're going. A heroic attempt to launch a cutting-edge technological apparatus on a quest to answer science's most important questions about stars, the galaxies, the planets, and the origin of our universe. Nowadays, when we think of a telescope, we think of Hubble. No other scientific tool became such an iconic symbol of our pop culture. Images made by this telescope are recognized worldwide. The Hubble Space Telescope rightfully acquired its glory by taking revolutionary pictures of our cosmos. In this ultra-deep field image, we can observe the result of the telescope staring for 11 days at a tiny segment of sky. It is almost like looking at the universe through a straw. An astonishing cluster of about 10,000 galaxies were found in this picture alone. Images like the one you're seeing right now allowed us to learn a remarkable amount of details about outer space, about its vast variety and complexity. But the telescope we're going to discuss in this episode will surpass Hubble in its size, capacity, and greatness. The James Webb Space Telescope. This technologically advanced product of the international scientific community will try to answer the questions and tackle the universal problems that none of its predecessors were capable of. But first, let's take a look at some key differences between James Webb and its famous cousin, the Hubble Space Telescope. The very first thing that catches the eye is the James Webb size. A 6.5-meter mirror versus the much smaller 2.4 meters of the Hubble's. In optics, the size of the telescope's mirror plays a crucial part. A bigger mirror collects more light and allows to see finer details. Sidewise, the JW is by far the biggest telescope that we've sent to outer space. The second major difference is the orbit. Hubble orbits the Earth at about 350 miles in altitude. The James Webb will be orbiting the Earth, Sun, and Moon at Lagrange 2 point, which is about 1 million miles away. Though extremely far away, it would be easy to communicate with and to keep it at a very low temperature, which leads us to a third major difference between the two: the type of light. Hubble is an optical telescope and works for the most part with a visible light. The JW is an infrared telescope that will be working in the red visible to mid-infrared spectrum. This particular distinction will allow us to see much further and to collect much more specifics than Hubble. But what will all this data allow us to learn? One of the major tasks of the James Webb is to get images of the pristine galaxies that were formed at the dawn of the universe. As of now, the most distant galaxies look like a tiny dot, just a few pixels across. But we know that even those galaxies are not the first ones to be formed. The JW will allow us to push that limit and to pierce time about 13.5 billion years back, in order to find out what the first galaxies looked like and how they form. The galaxies that we observe are of four types: spiral, elliptical, lenticular, and irregular. But more distant galaxies don't follow the same structure, and we want to know why. Along with galaxy formation, scientists are interested in the birth and formation of stars and protoplanetary systems. Arguably, the most important part of the telescope's research will be exoplanetary study. There are a multitude of questions that need to be answered, such as the formation of planets and the establishment of their habitable zones. This is Kepler orrery. It shows us just a fraction of the wide variety of planetary systems that the Kepler telescope discovered just recently, statistically confirming that virtually every single star has a planetary system of some sort. Imagine that just half a century ago, we thought that the only planets there are exist within our solar system. The James Webb Space Telescope will allow us to shift from knowing that the planets are there to knowing what they look like. It's done through a method called transit spectroscopy, where starlight passing through a planetary atmosphere carries the imprints of the planet's chemical components. A good example of a recently detected planetary system is TRAPPIST-1, located about 39 light-years away. Though the image presented by NASA is artist's illustration, it has to be not too far from how planets actually look like. Systems like TRAPPIST-1 would be a great target for the telescope to explore. The JW telescope's construction took decades. The project was conceived shortly after launching Hubble, as a response to astronomy's most relevant questions. After the scientific community survey in 2000, the James Webb Telescope got an endorsement and a seal of approval from scientists around the world. One of the most spectacular elements of the JW is its 18 hexagonal mirrors made of golden-plated beryllium to withstand the extreme temperatures of outer space. They are protected by a 5-layer sun shield, made with special protective coating to isolate the mirrors from the sun's light and heat. These and many other pieces of equipment are currently going through extensive testing to minimize any errors during autonomous work periods. 14 countries provided hardware components, which makes this project truly an international effort. The launch of James Webb Space Telescope is scheduled for October 2018. The monumental tasks are expected to be accomplished. A broad range of scientific issues, along with tens or maybe hundreds of unexpected surprises, are waiting to be discovered. Retrospectively, centuries ago humanity thought that everything to be discovered already has been discovered, that the shape and outlines of the universe are known, and nothing could be taken from or added to it. Due to lack of information, but mostly to underline the mentality of that historical period, we call it the Dark Ages. But it appears that just now we're starting to depart from our cosmic Dark Age, where people are confident of its centrality and exclusiveness in this universe. Upcoming discoveries will make us mentally prepared for the fact that we're not unique in space, and a new era of cosmic enlightenment, for better or worse, sooner or later, will come upon us.